I'm Violent and you're very welcome to my channel. Today we will use this, the Eowave Capsule Titan synthesizer, the synthesized analog drum sounds. We will create kick, snare, hi-hat, cymbal and all kinds of percussive sounds. Let's get started. The Capsule Titan contains two oscillators, a mixer, a filter, a VCA, an envelope generator and two LFOs. So we will use subtractive synthesis plus FM synthesis a little bit. To synthesize a kick drum, you basically need four modules: an oscillator, a filter, a VCA and an envelope. On these oscillators there is no sine wave. Sine wave is popular material in analog drum synthesis. So we will now use the square wave and we plug it to a mixer. Next comes the filter, then the VCA, and the envelope should be plugged into the VCA. Great! This is a traditional ADSR envelope, by the way. I'm just going to use the attack decay part of it. The micro ornamented crime will be the gate source. I start the gates and create the kick by the ratio of the pitch, cutoff and attack decay. That's good in itself, but a real kick drum is struck, so an exciter, a drumstick, is used to vibrate the skin, and that's how the resonant body sounds. This heat is usually created by modulating the frequency of the oscillator with another envelope. This envelope must be fast, because if it is not fast enough, it will distort the pitch. However, Capsule Titan doesn't have two envelopes, but its LFOs are syncable, and the mixer has an attenuator, so we'll try to use those. We connect the LFO 1 to the volt per octave input and set it to a waveform similar to a fast envelope, which is now an inverse ramp. Without sync, it messes up our kick tone, so it's important to sync. Since we need a fast envelope, we use the LED to set the LFO to be at least twice as fast as the gate. But we have to be careful not to set it too fast, because that usually leads to bad results. When searching, we can find several different sounds. Next, let's see a snare. We'll start from our kick patch, since we're creating the snare in a similar way. However, there is one important difference. Now we need a noise source. Here we run into another problem, as there is no noise on this synth. Never mind, there is another oscillator, and if you think about it, a noise source can be thought of as an oscillator that changes its pitch and waveform rapidly and hectically. Now, let's see what we can do about this situation on Capsule Titan. Firstly, the quick pitch change can be achieved with the LFO 2. We connect this LFO to the volt per octave input of the oscillator with the waveform set as noisy as possible. On this LFO here, we have a rather noisy waveform. Now, the LFO is set to fairly fast. We use the square wave signal again on the oscillator. Secondly, we're going to connect the saw output of the oscillator 2 to the pulse width modulation input. So we're going to modulate the timbre. We plug it into the mixer. For the snare, we need to open the filter more and set the decay to a longer volume. By adjusting the pitches of the oscillators and mixing them, we create the snare sound. To synthesize hi-hat, we use the noise we just made, plus the filter with the resonance turned up, so we're essentially making an oscillator out of that as well. First, we're going to set the envelope of our noise to very short. And then we're going to add the filter's sine wave. Setting the right cutoff value is very important here, as this parameter now adjusts both the presence of the high component and the pitch of the sine tone added by the filter. Since the oscillator 2 is still modulating our noise, we'll also set it higher here using this knob. It's also important to adjust the volume of the noise component appropriately. Now let's see the cymbal. We'll continue with our patch again, but this time we'll have to make a few changes. We're going to reduce the speed of LFO2 a little bit and plug it in place of LFO1, so that the pitch of oscillator 2 is now controlled by the LFO2. A saw waveform of oscillator 2 is connected to the pulse width modulation input of oscillator 1, and the output of LFO1 is connected to the VCA. This LFO should be slowed down. We want the sound to be more even, to have a rich spectrum rather than a timbre that jumps around in its components. Now we're using the full ADSR envelope to stretch out this sound, taking the attack off completely, bringing the sustain up a bit, raising the release to get a nice long ring. We turn the noise volume up to maximum in the mixer, add oscillator 2, and we preserve the self-oscillation in the filter. Interestingly, if we plug the inverted output of the mixer back into the sync input of the noise oscillator, it seems to straighten the sound even more, but on the other hand, it results in a slightly different timbre. Now we use this complex patch to synthesize all kinds of percussive sounds. We take out the cables of the modulation inputs of oscillator 2. The waveform of LFO2 is changed to square wave with random pulse width and slowed down. The LFO is now in the mixer, so we add it to our timbre, but now keep it to minimum. We take LFO1 out of the VCA, adjust the waveform to give random CV, speed it up a bit and plug it into the filter. On the filter there are two modulation inputs. This second one has an attenuator. We will use this one. We'll short the release on the envelope. The volume of oscillator 2 is reduced. The noise volume is minimized. By varying the parameters, we can synthesize tom, cowbell, and other undefined percussive sounds. There is nothing new in these techniques, they have been used for a long time. However, they are still useful today, and it's fun to use these techniques on an instrument on which not all of their methods are available. So we are pressed to substitute certain elements, forcing us to be creative. It is good to be confined in a framework, because this way it is easier to think of unusual solutions. Finally, if you like what you have seen and heard, hit that like button, subscribe to the channel, or both. Take care and see you next time. Bye.